For this video, we're finding the area of the region bound by y equals x cubed and the relation x equals y squared minus 2, which is a parabola opening in the positive x direction. So the problem with this problem is that if I actually look at little line segments, which to me represent very, very thin rectangles, then over here I have an issue because both the top and the bottom are touching the line for the same equation, the same curve. So if I actually did this with respect to x, then I would have to change and solve this equation for y, which would give me a positive square root and a negative square root, and it makes me break the problem up into pieces. Whereas if I just look at it a different way, say what if I was to add up rectangles that were going from left to right, then the problem gets much easier, because if you look at this, the right-hand side of each one of my rectangles would always be touching y equals x cubed, whereas the left-hand side are always touching x equals y squared minus 2. So if I'll just take a minute and actually just turn it and look at it a different way, I could do this as a dy problem much easier. So if I do this as a dy problem, you have to actually know your limits of integration, and they are y values from here to here. So for this problem, I'm going to call this A and this B. Now, how you would find those, which I'm not focusing on right now, would be to set these equal to each other, but I need y values. So what I'm going to do is actually right now, and I know I need to do this anyway because this is a dy, I would actually solve this and make it x equals instead of y equals. So I know x equals the cube root of y. So if I wanted to find my limits of integration, I would set the cube root of y equal to y squared minus 2 and solve that. Once I've done that, I can actually figure out what these values are. If you have a calculator, you can just ask the calculator to solve it, or solve it on the graphing screen, however you want to do it. Right now I'm just going to say it's going from A to B. Then what I need is the more positive side, and that is the cubic function, but this is with respect to y, so I'll be using the cube root of y. And I will subtract out the less positive, which is y squared minus 2, and it's already with respect to y, so minus y squared plus 2. And if I integrate this expression, once I know what A and B are, I would get the area of that region.